Good day, Prof. We are Team 14. Today we'll be presenting our IoT group project. I am Renuka. Together I'm joined with Coco, Ivy, Jocelyn, and Jack. So now let me kickstart with our introduction. Our main focus was on the sustainable urban agriculture, specifically on hydroponics. So for our main objects, we aim to democratize hydroponics, making it accessible to budget-conscious users in Singapore. By providing affordable solutions, we envision a future where hydroponics is not just a niche practice, but a mainstream method of farming in urban environments. To achieve this, we developed an IoT-driven hydroponics management system. This system will not only merge hydroponics with urban farming, but also foster resource-efficient practices, ensuring that our urban agriculture is sustainable for the long term.
Hi, I'm Coco, and now I'll be talking about the main features of our system. To ensure efficient plant growth, it is important to keep track of plant water levels and nutrient levels whenever we water our plants or fertilize them. Hence, there are sensors to track our water level and nutrient level of the plants in our hydroponic system. For the hardware and software used in our app, we utilize sensors to collect environmental data related to the plants, such as water and nutrient levels. We use M56C Plus to communicate with each other and also the Django server via MQTT messages. In addition, our front-end database and back-end server was developed using Django to handle incoming requests from our M56C Plus and to serve the data to the user interface. Now I'll pass my time on to Ivy.
Okay, so now we'll be talking about Postgres. So we have the user, which is the user ID, name, email, password, and so on. We also have their plant, which is the plant ID, name, floor, public or private, etc. And we have the sensor data, which contains the water level, nutrient level, and plant ID. Okay, so now we'll be talking about the MQTT. So we have the publisher, the broker, and the subscriber. So for the publisher, the MPI stick will be publishing the sensor data over to the Django, which will publish the commands. The broker will be the central hub to dispatch all messages, and the subscriber will be the MPI stick and Django, which both subscribes to the same topic to receive the data or commands.
Next, for our Django server, it serves as the backbone of our application, while providing a comprehensive dashboard for managing plants within a HDB, offering insights into each plant's status and conditions. Sensor data collected by M56C Plus devices is seamlessly integrated into the dashboard, allowing users to track vital metrics such as water levels and nutrient levels. Moreover, users have control over plant care through intuitive controls that enable actions like watering, fertilizing, and configuring auto-watering systems. All in-depth information, including data readings, last watered, and last fertilized timestamps, are securely stored in a database, ensuring data integrity and accessibility for informed decision-making and plant maintenance scheduling. Moving on, this is our web UI. The image showcases the homepage of our website with all the plants in a HDB, separated by the levels and the individual plants on each level. So users can add new plants as and when they like from the green button at the right side, as well as viewing their own plants by switching to My Plants. Next, upon clicking on the plant itself, you'll be brought to a page where more information about that plant is being showcased, such as water, fertilize, auto on-off watering, and delete features.
So for our system architecture, our core is the M56C Plus devices. Each of these is directly connected to water level sensors and nutrient level sensors, along with a water pump actuator. This setup forms the basic unit of our sensing and control mechanism. The sensors continuously monitor the water's pH levels and the water level in real time, which is crucial for maintaining the desired environmental conditions. The water pumps are then controlled based on this data when needed. These M56C Plus devices then connects to our central system via Wi-Fi. This ensures wireless connectivity that enables ease of installation and flexibility in sensor placement. The MQTT protocol comes into play here, providing a lightweight and efficient messaging system. This is where data is published by our devices and then relayed to the MQTT broker. On the other side of the MQTT broker, we have our application server, which is built on Django. This server is responsible for processing the data received from the MQTT broker and then sends it into our Postgres database. This database is robust and scalable, ensuring that we can handle high volumes of data that comes from the various individual zones, which will each represent a floor of our HDB building. And finally, we bring this all together in a user-friendly dashboard, which is also built using Django for the front end. This dashboard is where the magic happens for our end users. It provides them with the real-time insights, historical data analysis, and control over the entire system. So now I'll talk about the conclusion for our project. So the benefits are that there's real-time monitoring and control of plants. Because of our integration of water level, nutrient level sensors with the M56C+ devices, this allows for continuous monitoring and automated control of water quality, which is essential for optimal plant growth. Then scalability. Because of our system's use of MQTT, a lightweight messaging protocol, this means it can be scaled to accommodate more sensors or control additional devices without significant changes to the infrastructure. Then remote accessibility. Because we chose to use Django for our application server alongside a dashboard interface, this means that users can access real-time data and system controls remotely, promoting convenience and flexibility. Then for other contexts where our project can be useful, firstly, it will be urban farming, because the system's compact and scalable architecture makes it an excellent solution for an urban farming setup, where space is limited and precision farming is required to maximize yield. Then for aquaculture, by adapting the sensors to measure parameters crucial for aquatic life, this system could be used to manage water quality in fish farming or aquaponics. Lastly, we have environmental monitoring. By expanding our sensor array to include air quality or soil moisture sensors, it could allow for broader environmental monitoring, aiding in data collection for climate research. Now we'll move on to the demonstration video, which will showcase how our IoT solution works. So this is the demo for our IoT project called IoT Farmer. This is our Django UI, which showcases all the plants in our HDB building. Then, here we have two different M5 sticks, which will represent two of the plants in our HDB building. Then all this is communicated through MQTT broker. So now, to determine which M5 stick represents which plant, we will press a button on the M5 stick, which will then send data to the back end. As you can see, it says plant ID 7. So now if we go to the database, if we refresh, we should see another entry from plant ID 7. There's an extra entry here. Now, we'll try the other M5 stick, and it says plant ID 8. So now if I go to our database, refresh, we should have 15 rows. As you can see, there's 15 rows, and it's from 8. So now I'll go into the controls on the Django side. So we go into plant 7. Here is the statistics page and the controls for the plants. So if I press water plant, it should only reflect on one of the M5 stick, which is the ID7 M5 stick, the one on top. So if I press water plant, as you can see, only the one on top has the message that says watering plant 7. Now if I swap plants and go to plant 8, now I'm going to water plant 8, so only the bottom M5 stick should have a message. As you can see, only the bottom one has a new message. Now we can also fertilize plants. So I'll go back to plant 7 and I'll press the fertilize button. As you can see again, only the top one has fertilizing plant 7. And then lastly, we'll fertilize plant 8. So as you can see, only the bottom one has the fertilizing plant 8. So all the data is saved into our Postgres. That's our chosen database for this project. And everything is communicated through MQTT, publish and subscribe method. That's it for our demo. Thank you for watching.